Namaste everyone. Welcome to first lecture of magnetic effects of electric current. Now let us first see syllabus. The first topic which we going to study is magnetic field, then field lines, field due to current carrying conductors, field due to current carrying coil or solenoid, force on current carrying conductor, Fleming's left hand rule, electric motor, electromagnetic induction, induced potential difference, induced current, Fleming's right hand rule, electric generator, direct current, alternating current, frequency of AC, advantages of AC over DC, and finally we see domestic electric circuits. Now the term magnetic effect of electric current means that an electric current flowing in a wire produces a magnetic field around it. In the last chapter we have seen the heating effect of electric current. Now we have seen that when current is flowing through a conductor, then heat is generating in the conductor. In this chapter we will see one more property, that when current is flowing in a conductor, then it creates some magnetic field around itself. That means it behaves in magnetic form, it behaves as a magnet. So before we discuss in more detail, let us first understand what is magnet, what is a magnetic effect, right? So a magnet is an object which attracts pieces of iron, steel, nickel and cobalt. Magnets come in various shapes and sizes depending on their intended use. One of the most common magnet is a bar magnet. Now a bar magnet is a long rectangular bar of uniform cross section which attracts pieces of iron, steel, nickel and cobalt. We normally use the bar magnet for performing practicals in science laboratory. A magnet has two poles near its end, north pole and south pole. You can see in the diagram north pole and south pole. The end of freely suspended magnet which point towards the north direction is called north pole of the magnet, and end of the freely suspended magnet which points towards the south direction is called south pole of the magnet. It has been found experimentally that like poles of magnet repel each other, that is, north pole of one magnet repel north pole of another magnet, and similarly south pole of one magnet repel the south pole of another magnet. And unlike poles, they attract each other. So north pole of one magnet attract the south pole of other magnet and vice versa. So for bar magnet we see that north pole point towards north, south pole points towards south, like poles repel each other and unlike poles attract each other. Now if I break this bar magnet, suppose if I cut this bar magnet at this particular point, then it is not like a key I have only north pole in this magnet and only south pole in this magnet. When I cut this bar, then again this part have north pole and south pole. When I cut again, then again I have north pole and south pole. So that means north pole and south pole, they always exist together, right? You cannot have only north pole or only south pole. So we have understand what is a magnet. It is some object which attracts iron, steel, nickel, cobalt, like those items, like those objects. Now there are various uses of magnets. We can use magnet, or we generally use magnet in radio, television, in refrigerator doors, in audio and video cassettes, hard disk, floppies of the computers, in children's toys. Magnets are also used for making electric generators, electric motors. MRI, which is magnetic resonance imaging technique, which is used to scan the inner human body parts in hospitals, also uses magnets for its working. So these are various uses of the magnets. Now let us understand magnetic field. The space surrounding a magnet in which magnetic force is exerted is called a magnetic field, right? I think we have studied gravitational field, we have studied electric field. Similarly, we have magnetic field. So let us first again revise what we understand by field. Now we know that whenever we have to apply force on some object, we have to have a physical contact with that. That means we push or pull, there should be some physical contact when I am applying a force. It was found that without having physical contact also the force can be applied, right? Suppose if I put an object in air, then what happens? That object falls on the ground. Now why that object is falling on the ground? Because earth is attracting. Now earth is not in contact with that object, but it attracts that object towards itself. So the space around earth has got some property which is applying force, which is pulling that object down. So that space around earth in which the force of earth is exerted is called gravitational force, a gravitational field. Similarly, around a charge we have an electric field in which if I put any other charge, then that charge experiences a force, so we have electric field. And in the same manner, when I have a magnet, then if I put some iron filing or something at some distance from the magnet, then that magnet can pull it. That means the space around magnet has got now certain property because of which it can attract that iron filing. So this area around the magnet in which the force of magnet is experienced is magnetic field, right? So I hope you understand what is magnetic field. It is a space surrounding a magnet in which magnetic force is exerted is called magnetic field. The direction of this magnetic field at a point is the direction of resultant force acting on hypothetical north pole placed at that point. Okay, now again I will take an example of that gravitational field. So in gravitational field, if I put an object, what happens? It moves towards the earth. The direction in which that object moves gives me the direction of gravitational force. That gives me the direction of gravitational field, I can say. Similarly, if I put a charge in electric field, then the direction in which that charge moves gives me the direction of electric field. In the similar manner, if I put an hypothetical north pole in the space around the magnet, then that hypothetical north pole will move in a particular direction. The direction in which this hypothetical north pole will move gives me the direction of magnetic field. Now here I am using word hypothetical north pole. As I discussed before that north pole and south pole I cannot separate them. But here for understanding we are considering only north pole to get an idea about the direction in which the magnetic field can be experienced. Now let us understand magnetic field lines. We have understood magnetic field, we have understood the direction of magnetic field. Now this is a space around magnet. So how we represent that? So for that we need some lines, we need some drawing. So that drawing or that lines are nothing but magnetic field lines. You can see in this diagram we have a bar magnet and we have shown few lines around this bar magnet. So these lines which we have shown around a bar magnet, they are nothing but magnetic field lines. The magnetic field lines are the lines drawn in magnetic field along which a north pole would move. So as discussed earlier, I will consider only the north pole. So the north pole which will move in this magnetic field, their path I will trace, and that gives me the magnetic field lines. The direction of magnetic field at a point is the direction of resultant force acting on a hypothetical north pole placed at that point. So let us see this curve. Here I am moving, suppose, from this left end to right end. At different points, okay, we have drawn some tangents. Now you all know what is tangent. So you can see that at this point we have drawn one tangent, at this point we have drawn tangent, at this point we have drawn tangent. So these tangents, they indicate the direction in which I am moving at different points. So when I am at this point, this tangent indicates that I am moving in this horizontal direction. When I am at this point, then this tangent indicates me the direction that I am moving in this direction, right? Similarly here, these curves at different points, you will draw tangent, and those tangents will give you the direction in which the North Pole will move, or you can say that the direction of magnetic field, right? So the direction of magnetic field at a point is the direction of resultant force acting on the hypothetical North Pole placed at that point. I hope you are clear with this magnetic field line, the concept of this magnetic field lines. So they are nothing but they are some graphical representation of magnetic field. By seeing the lines, we can understand the direction in which force is acting. Also, the crowdedness of these lines indicate the strength of magnetic field, the strength of magnetic force. So where the lines are more crowded, there the force is more. Where they are less crowded, there the force is less. So we can see that the force is more near this north and south pole, and it is less at other places. Now let us see how to plot the magnetic lines. There are two ways which we discuss here. One is due to bar magnet by using iron filings. Now you see this diagram. What we have done, we have placed a bar magnet on the card paper. Then we sprinkle some iron filings around this bar magnet. Then we gently tap that cardboard, and because of tapping, what happens, those iron filings, they slightly lift up, and there is no contact between cardboard and iron filings, and because of that the force of friction is not there, and hence iron filings move under the influence of magnet, and they all arrange themselves like shown in the diagram. You can see some videos on the YouTube where you have clear idea how these iron filings are arranging themselves. So after some time you find that most of the iron filings, they are near north and south pole, and other iron filings, they are arranged themselves in the pattern as shown in the diagram. So based on this pattern only, we have drawn the magnetic field line which you have seen in the previous slide. This is one way of drawing magnetic field line. The other way of plotting the magnetic field line is by using compass. So here you can see that I have a bar magnet, and here a compass. You all know compass, it has got one needle which indicates the north direction. So arrow indicates the north direction and the other end indicates the south direction. So what we have said, that it is the direction in which my north pole is moving. So if I put the compass here, then you see that north point is here, the north point of needle is at this point. So what I will do, I will mark this direction with a pencil, and then I move this compass from here and I put this position so that its south end is at this particular point right now. So you can see that this end is here at the head of this north point. Now this needle is showing this direction, so this is the direction in which north pole is moving. So again what I will do, I will move this compass and I will put in this particular position. So like that I will continue and I will get this particular path. So I will draw one line. Next I will move this compass at some other position and I will again trace up. So at different positions I put this compass and trace the path. What I get arrangement, or I get lines similar what I get in the case of iron filings. So these are two ways of drawing magnetic field lines. One is by using iron filings and other by using compass. Now let us understand properties of magnetic field lines. Magnetic field lines emerges from north pole and merges at the south pole. So as we discussed, okay, they are starting from this north pole and ending at south pole. Starting and ending is not correct word. They are emerging from north pole and merging at south pole. When I am saying merging, that means inside magnet also they are moving. So outside magnet they are moving from north to south, and inside magnet they move from south to north. The direction of magnetic field inside the magnet is from south to north. This is second property. Third is the strength of magnetic field is shown by the degree of closeness of the field line. The field is stronger where the field lines are crowded. So this also we have discussed. So So you can see that here they are more crowded. So here the strength of magnetic field is more, or I can say that there is more magnetic force. The magnetic lines do not intersect each other, right? You can see that these lines, they are not crossing each other. Why they are not crossing each other? So as discussed, these lines, they also indicate the direction in which the North Pole is moving. So suppose if I have a North Pole at this point, then North Pole is moving in this direction. Now suppose they are crossing, then in that case what happens? At the point of crossing, the North Pole has got two directions, that is, it is now moving in two directions, which is impossible. So therefore we say that magnetic lines, they do not intersect with each other. I hope this fourth point is clear to you. I am saying that if suppose the two lines are crossing, then the point where they are crossing, that point indicates two directions, right? If you draw tangent, then you will get two different tangents, that means two different directions, which is impossible for any particular North Pole or any particular object to move in at a particular instant. So magnetic lines, they do not intersect each other. So we wind up our lecture here. Let us just revise, have a quick revision what we have done in this lecture. We have seen the syllabus, what we have to study in 10th standard. Then we have seen what we mean by magnetic effect of electric current. We understand magnet, bar magnet. We understand about magnetic field lines, and we have seen few properties of magnetic field lines. Thank you.